Hi everybody, I'm Till Kamppeter. I'm the leader of Open Printing, and therefore I'm responsible that printing just works on most operating systems, Linux, POSIX style operating systems and so on. And so I'm the printing guru for free software, and this I do already since mid-2000. And so it's 25 years for me for doing it. And also due to the fact that I've made a snap of the printing system of cups, I came to snapping, and with the Ubuntu summits, I came to the idea to create snap workshops, and there we had then one with my organization 5 snap workshops in the Ubuntu Summit 2022, and after that we have continued with the idea and given snap workshops. Yes, and therefore we have these nice snap workshops on many conferences.
I'm Soumyadeep Ghosh. I am a part of the Ubuntu governance team and the Ubuntu membership board. And from last year, UbuCon Asia 2024, till invited me to be a guest speaker for this same workshop. And then we did the same workshop at the summit, Ubuntu Summit 2024, at The Hague. And then, well, you can see this year we are going to do it with you. We are going to explain you about snaps. We are going to introduce you about the packaging status of Linux and in Ubuntu, how things are being done. And let's just talk about a bit of past iterations. Like this workshop was initially started with Heather Ellsworth and Lucy Lelewin. They were the first iterators of this workshop. I think it was from Ubuntu Summit.
This was the first Ubuntu Summit 2022 in Prague, where I've organized this mentioned Snap workshop series, and the first of the series Heather and Lucy have given. This was the beginners workshop, and this is the workshop we will give now.
And the next one you can see at the UbuCon Asia. And we didn't have a space to add a picture for last year, but at the Ubuntu Summit, me, Till, and Martin Sebrex from Snapcrafters, we did the same workshop at the summit. So let's start the workshop. So first of all, you need to install Snapd. I hope that most of us, if you're using Ubuntu, it's pre-installed. It's pre-installed, and the rest of the setup you can see go through markdown documentation attached in the talks materials section. You can go through that, and you can install Snapd. You can install Snapcraft, and you can install LXD directly from all these instructions are also given in that workthrough documentation. Like if you have these things installed, then we can go ahead, or if it's not, we can wait for 5 minutes or 10 minutes, so that like most of the attendees have this installed. And I think those who are with Macs, you guys can also use Snapcraft and Snapd. So you have it installed. Great. So I think even one can use multipass to build snaps.
Yes. For Macs, one or if you have an operating system or a Linux distribution which is not compatible with Snapcraft, in any case you can use a virtual machine with multipass, for example, on Mac, and even on Windows you can use WSL, but I assume that nobody here is using Windows. So for everyone to find the instruction file, you go to the UbuCon Asia page, to the timetable, and then you click in the timetable on this workshop, and then you click on the description or on the pop-up, and then you get onto the page of the workshop. And on this page you scroll down, and under conference materials, there you find the slides and the instruction file, and these you can download.
Those who are using Mac OS, they can use multipass to get a VM and get Snapcraft and Snapd working inside those VMs. And those who are using like like Linux, or they can easily get this thing working through documentation. Yes. Using Kali, right? Most of the attendees have this thing set up working or not. Snapcraft, Snapd. Can we have a response, please, from everyone? Those who have Snapd and Snapcraft working, please raise your hands. Okay, so for those who do not have this setup already, it's running. So we are going ahead, but you can always come to us to like ask about. So let's talk a bit about, like, until then, those who are still setting things up. Let's talk about a bit about the packaging system itself. How, like, what is Snap? So do you guys know about app, or any like do you guys know about app? Do you guys know about DNF from like other systems? Do you guys know about Pacman? So what are these? What do you guys think? What are these? DNF, app, what are these? Package managers. And what do you think? Dev, RPM, what are these? Do you guys think? Yes, but these are actually packaging formats. So devs and RPMs, these are packaging formats, and apt, DNF, these are the package managers. Those who manage all the packages that have installed in your system. So Snapd is kind of a mix of both. Snapd can maintain or manage all the packages that you have installed in your system, and the Snap is the format, the .snap file that you will get. I hope most of you get the .snap file after this, at the end of this workshop. And so a Snap, how do you guys, like, what do you guys think about immutable applications, immutable containers? What do you guys know about this, or what do you guys think about this kind of things? Like immutable, which a container that you cannot really change anything. What do you guys think about? Have you ever tried anything Snap or Flatpak things? Have you tried? Okay, okay. Uh, have you ever tried any CLI application that is immutable? Have you ever tried a CLI application that you cannot really change anything? Like, you just install it and you forget about it. It will auto update in the background, and you don't really think about the security. You don't really think about the security, that okay, it might access this random files in my system. This might access this random files in my system. Have you tried? What? No. Is it immutable? Like it's in a format, like in a packaging format. LS is basically like you have installed LS as a Debian package or an RPM package. Right? I'm talking about a packaging format that is immutable in the sense that is containerized. Have you tried in that way? And CLI application, or like you guys have used flat packs, right? A lot of give a response about flat packs, using flat packs. So okay, but we're not here to talk about flat packs. So snaps are basically this containerized solutions, but it's not only for GUI apps compared to other counterparts. It's not really for GUI apps. It's also for daemons. This guy made a snap of cups, and it's also for CLI apps. So if you want to share about the daemon thing.
Yes. One special thing what Snap can do, what Flatpak cannot do, is that Snap can, with Snap you can package everything, not only desktop applications, but CLI applications, daemons, system applications, even the kernel and the boot system you can snap. So you can make on all Snap operating system, which was created together with Snap. It's Ubuntu Core. And so I have Snap, and I came to Snap because I have snapped cups. And cups, the print environment, this is a daemon. This is running in the background, and this one can also snap. And this way, if you have a snap-based immutable distribution, you can also replace and exchange and update system components without needing to update the whole system, which is the case on immutable distributions which use Flatpak for adding desktop applications. And therefore, because I've snapped cups, I've also created a Daemon Snappers workshop. We will not have it on this conference, but it's on the internet. One can download it and one can work through it by oneself. And so Snap Snap gives you this possibility, and Snap is also very close. The concept of Snap is also very close to applications on smartphones. You get snaps from the Snap Store, install them easily. They are atomically replaced on an update, so you get very reliable updates. And if something does not work, you can the previous version is conserved on your system. You can step back to the previous version. And when you have an Ubuntu core operating system, and when an update of the kernel or the boot system does not work out, and the system does not boot anymore, it automatically steps back to the previous version and then boots. So what one perceives in such a case is that it only takes a little bit longer to boot, but it then finally boots the old version. Yes, and these are important things which you can do with Snap. And in this workshop, the most common case for somebody creating snaps is desktop or CLI, command line applications. Our examples are of applications. We will not snap the kernel in this workshop. And also not cups. And another thing is, the snaps are distribution independent packages. You can install snaps on any Linux distribution on which you can install snapd. And you can install snapd on most distributions. There are instructions on snapcraft.io. And so you can install, so you can solve, for example, the problem for printer and scanner drivers that the manufacturer must create them for many distros with classic packaging. With Snap, it's not needed anymore, because with Snap you can package the drivers, as Snap can do more than desktop applications, and Snap is distribution independent, so you can make distribution independent packages of printer and scanner drivers. And this way, it gets easier for hardware manufacturers to support Linux.
So this is a last resort for those who are not getting the setup working. If you have VirtualBox or VMware installed, we have also attached the images for VirtualBox and VMware. You can directly download it. I believe will need a LAN connection for that, because it's almost 9 gigabytes of the image sizes. So you can install it and directly run those images from VirtualBox or VMware. So those who have not completed the setup, or who are getting some problems with the setup, they can use that as a last resort. So let's get ahead with the session. And so as I was talking about that snaps, and Till was talking about this demon in a snap. So snaps doesn't really fear demons, you know. Let's
yes,
so
don't fear the demons. We snap them too.
So what happens when you package an app as a snap? You can directly publish it via the Snap Store, and a snap will automatically update itself in the background. You don't need to worry about your app being updated or not, your app being like having some CVEs, because those things are already like looked ahead or looked into by Snap Store itself. You don't need to think about these things at all. Now, do you guys have any application in your mind that you want in your package manager, or you want to install without any kind of hassle? Like, it might be very problematic to install it, and you just want a package manager to do it for you. Like, you run sudo apt install, sudo snap install, and you get this thing running. Do you guys have any such application in your mind? And if you have any mind, we can go ahead with the workshop on that application. You can work on that, and we will obviously go ahead and help you with that. Else, we can take our like all size fits in one example, the GTK Hello example. Still, can you just show the slide? So we have this example snap, the GTK Hello World app. which will today, if you guys don't have any other application in your mind, which we will build today, first without any snap, like without outside of the snaps container, and then inside the snap container, like we'll build the snap of this hello world application. So let's get started. Next slide, please. So please go to this URL and download the source code for the GTK Hello World app, and then please go through with this setup, like installing the build dependencies, which is mostly one, like the GTK libgtk4 development files.
What is?
So here I think the dev got put down.
Yes, it's missing. Now I see it.
So yes, you can. You can also clone the GitHub repo that we have shared. The Hello World example is also being there, so you can also clone that and get the thing working. Like build the app, and let us know who are not having some issues or who are not able to build the app from source. So we just open the walkthrough documentation. Don't close the walkthrough documentation in GitHub.
If you are looking into in the timetable of this conference and do not find the instruction files, note that if you get the timetable via WhatsApp, there are not the links. You always have to go to the website of the conference if someone is still not getting the files.
Let me just show that with you guys. Yes, first just roll the whole.
Step back to the home page of.
So this is our GitHub walkthrough documentation that you guys need to clone, or you can get it from the official source also, which we have already added in the materials. And you can also clone this URL, and you can build this GTK Hello World snap from here. You will also get the source code from here. So you can see the SRC folder. Is it visible now? So you will get the source file here and also the snapcraft YAML, which we'll talk about a bit later. So if you just clone this URL, which is snapcrafters/snaps quickstart guide, just clone this URL, and now go cd into the src folder, like cd hello world gtk and then into the src folder if you have cloned it in there. So cd into the src folder, hello world gtk/src folder, and next you install the build dependencies, that is sudo apt install, or if in case yours is a different distro, then look for the gtk4 development libraries. For Ubuntu and derivatives, it's libgtk4 minus dev. The dev got cut out a bit, I'm sorry for that. If you are already in the source folder, src folder that contains the .c file, you just run this command to build it locally. You also need the development files, obviously, but I hope everyone has installed the development files, and you run this command, and this will build the Hello GTK World example app from source outside of Snap. This is not inside the Snap. We haven't entered the Snap chapter yet. So this is just to give you an idea of how to build things from source. Has anyone been successful in building the Hello World GTK binary from source? Please raise your hands, those who have been successful in building it from source. Those who are having some issues, please let us know. Maybe by raising your hands, maybe by calling me that this is the issue that we are having. So this Hello World GTK part got mixed out due to the upscaling. So the whole command is gcc, and then this command package config cflux is basically cflux get the cflags needed to build this library. It basically points to the folders that contains this header files for GTK4. So I'm very sorry those who have run the wrong command. I'm very sorry for that. Like we upscaled this and this from -4 it got this part cut out and so now it works. So is it working now? Can you raise your hand those who have got it successfully working? Okay, great. So now if you yes. So now if you run the binary, you will get the GTK4 window. Yes. So clone this. Have you cloned the directory? Have you cloned? So where is the source code? So have you copied this? Is it in the hello world GTK file? What's the file name? Those who have been able to successfully build this app from source, they should get this thing. This is a very old screenshot, but something similar to this showing up in your display. So, congratulations, a big congratulations, those who have been able to successfully build this from source, because you have successfully built an app completely from source using its header files, and you are not depending on any package manager. Now, let's build this same thing, but as a snap. Shall we? So, can you please raise your hands, those who have been successfully able to build this from source? Those who are getting a failed to open display error, they can also raise their hands. They are also successful building it. So please raise your hands. Okay. I think we can go ahead. I think we can go ahead with the next step. So now entering into the snap world. So you already have, like, those who have cloned our GitHub walkthrough page, they already have the snapdraft YAML file in the source code. With the source code, they also get the snapcraft.yaml file. Those who have copied it from the GTK docs, or those who don't have the snapcraft YAML for you, you can run snapcraft init to get a skeleton of snapcraft. It's an empty template, and then you can go through with this and fill it up. So I hope that everyone has a snapcraft YAML file already. Or if not, run this inside your source folder. Run this command. Snapcraft init. This will initialize an empty snapcraft template within your source folder. So let's discuss a bit about the skeleton itself. This is an example that I have taken from KCalc. If you know, like, if you have run KDE, it's the calculator of the default calculator of KDE environment. So first, come to the point of metadata. What metadata does a snap have? A snap can have a name. Obviously, that's the main key thing that distinguishes a snap from another snap in the store also. Like, every name a snap has, like, for example, KCalc or the Hello World GTK that we are going to have, it's a unique identifier of that snap. Like, that's not the only unique identifier that one snap has, but that's also that name. That name keyword is also a unique identifier of a snap. Next comes obviously the version, a summary and a description. This can also be adopted from the AppStream metadata file if you know about AppStream, and we can come to these things later. Like, you get the idea from the name itself. A summary is just a one-liner punchline for your app, and a description is 2-3 lines explaining that this is my awesome app. It does awesome things. It does rm-rf/. Okay, and now let's come to a bit of snap things. You see the keyword here, confinement. So as I already told you that snaps are confined. Snaps are containerized. So this keyword tells Snapd or Snapcraft that this is a strict snap, which means this is a confined snap. It has no direct access to your system resources until and unless you give it the access. Or the snap maker who has built this snap has added a provision to give this snap access to your system resource, that particular system resource. Maybe it's accessing your display server, well, and xorg, maybe accessing your home folder. /home, or maybe accessing your SSDs or the removable medias that you have mounted, right? So all these things. Yes. Let's come to it later. Okay, so all this things comes from this part. We'll talk about this a bit later. The confinement, the giving access to your app comes from this particular part. The plugs. The plugs and slots are the mechanism that Snaps uses to talk with your system resources via defined set of rules. App armor rules. I guess a lot of you heard about app armor in the keynote session. So app armor rules are predefined set of app armor rules. Those have been defined in Snapd, and all of this home OpenGL, this has a set of rules, set of app armor rules set by Snapd, predefined, and this app armor rules gives this Snap access to your system resources. So we'll come to this part later. So as I already talked about confinement. You see, I have written here strict, because obviously this is a strictly confined Snap. This Snap cannot access your system resources without your permission, your exclusive permission. Without your exclusive permission, this Snap cannot access any of your system resources. But there is another type of Snap. Let's say you are using a compiler, GCC, and you have snapped it. It is possible, obviously, but GCC needs to access any random system level header files, right? For example, the GTK one that we just tried. So how is that possible? Like, will we go ahead and give it every single arbitrary paths that it can access, it might access? So there comes another confinement keyword, that another type of confinement, which is basically giving the Snap a similar type of access that a diff package have in your system. That's called classic. So when a Snap is confined as a classic Snap, it can access any arbitrary files in your system. So definitely there is a lot of limitations which snaps can be snapped or packaged as a classically confined Snap. Which snaps or which publishers can actually publish such a Snap to the Snap store. These are all regulated, so that one cannot just go ahead and misuse this thing that, okay, I want a classic Snap, I will just create a classic Snap, and then I will do sudo rm minus rf slash. Okay, now comes to the apps part. You see this apps, there are some keywords under the apps section, like kcalc is the app name, and then common ID. You'll see this is the app stream ID that's being used, the app stream unique identifier, the command that runs kcal. This is from core 18, so this is a bit outdated. This command thing is a bit outdated. Like we'll talk about this later. The extensions, your extensions is like this shared libraries that a Snap can use. Like for example, there can be many Snaps that can use libraries that are shipped by KDE, by GNOME, like the libgtk4. For KDE, it can be something KF6 framework or something like that. So instead of every single Snap shipping their own libraries, these extensions give them access to a shared runtime. At the runtime, that's the name suggests, a shared runtime. And now coming to the plugs. So as I already told you before, plugs are the system that a Snap can talk with your system resources, can use your system resources through this plugs and slots mechanism. So you see a lot of slots are being plugs are being mentioned here: home, OpenGL, network bind. So I don't want to discuss. I don't want to dig deep about what all these things do. But a general idea is that when you connect your Snap with this plug, for example, let's say you connected the home plug with your Snap, like you gave your Snap access to your, so like that translates to, like for us, is that your Snap now has access to the home directory of your system. So your Snap can do read and write in your home directory, any file, any top level file, not the hidden files like the dot, hidden by the dot prefix suffix. Yeah. So someone was asking about the base. So the base is the, like, every single binary that you use. For example, GCC, it's C. So it requires C libraries, right? It requires the standard libraries of C. So does every single Snap should ship their own C libraries? standard libraries? Is it necessary? This is where this base comes from. You see the name Core 18? This is basically a base of Ubuntu 2018.04. The latest base that we have is Core 24, which is a base of Ubuntu 24.04, the LTS release. Every single LTS release has its own base, which is an updated one than the previous version, as you can understand, like from the releases itself. So the base is basically a very trimmed, a very strict version of Ubuntu, the latest Ubuntu LTS, that is giving all these standard libraries required for any single application to run. The libc ones, the glibc, the C++ headers, the standard files, for every single thing. So now let's go ahead and let's build the Hello World GTK snap, like the app as a snap. Let's go ahead with that. Next slide. So you see this snapcraft YAML file? Can you open it if you have? If you don't have, I will show you the command snapcraft init. That will give you the boilerplate template. So next slide, please. Yeah. So you see, as I explained before, the name as a metadata, you need the name, you need the version, summary, and description. So does everyone have the snapcraft YAML file in their source folder? As I have already explained a bit about the snapcraft YAML structure, would you guys want to nuke your system and let's just build the snap first from the existing snap manifest? Do you trust us? I hope you do. I hope you do trust us that we have provided a good enough snapcraft YAML. So let's just do one thing. Let's build the snap that is already there. So from the top level of that directory, I open a terminal in that directory and just run snapcraft or snapcraft -v to get a bit of logs to see what's actually working or what's actually snapcraft doing with that thing. Can everyone run snapcraft in the top level folder where the snapcraft.yaml file exists? And if anyone is getting some error, please raise your hands and let us know that. So for those who are having issues with snapcraft like LXD and things, so when you add a user to the LXD group, you generally have to reboot. Or what you can do is you can like run this command, new group, and then LXD. This is after you add your user to the LXD group. You just run this command, and then you run LXD init auto. In case if you are having some issues, you run these two commands, and then the commands that we said about snapcraft or snapcraft -v to get more logs. Let's open up the snapcraft.yaml file. Let's open up the snapcraft.yaml file and let's understand what's happening. What kind of malware are we sharing with you? So let's open that up. So you can see the first thing that it says is name. As we said before, name is the UID, the unique identifier of a snap. It is one of the unique identifiers. I must repeat myself again. It is one of the unique identifiers of a snap, the name. Then the version. These two things, not only these two, these four things. Name, version, summary, and description. These four things are very, very mandatory for your snap, for a snap to work. Now, base. Someone asked from here that what's core 18, what's base? You see here it's not core 18, it's core 24. So this means that we are using the base, we are using the chiseled, stripped version of Ubuntu 24.04 LTS, which contains the libc binaries, some glues that are needed for snaps to work, some glues for xdg open like commands, which are very like essential for the basic or the whole Linux ecosystem to open random URLs in your default browser and all. So this kind of commands are necessary. And then the confinement. As I already told you before, the confinement here has to be strict. If it's a snap, it's a regular snap, there is a 90% chance that your snap or your application will work easily with a strict confinement. I hope nobody has question until this part. This is the metadata section, and then we can go ahead to the app section. I hope no. If anybody has any question about this metadata section, they can obviously ask me now. So so now going ahead with the app section. What is this? So we are giving our like a snap. A snap can have multiple executables. An app is basically an executable for a snap. So a snap can have multiple executables, right? For example, let's say I have snap LibreOffice. So there is LibreOffice Start Center, there is LibreOffice Calc, there is LibreOffice Spreadsheets. Nice tongue twister. And for us, luckily, Hello World GTK has only one executable. That's the Hello World GTK. So we are saying we are going to use the runtime of GNOME. That's why I said extensions, and there can be multiple extensions. So it's a list. So we're saying extensions GNOME. Next, we're saying command. Command is a binary path. Is the path of that binary file, like the binary file that we will build later. You see, we are like in the part section when you go later parts. You can see that we are building this Hello World GTK binary file, which we actually run in the previous setup where we didn't build it inside a snap. We built it in the new actual hardware. This is a path of this binary file. I'll talk about this a bit later. And then the plugs. This is just for example. We have given access to removable media. Like this gives access to your peripherals, your storage peripherals that you add. This snap doesn't really need access to it. And now the slots. So as you might know, every single GTK app uses dbus to communicate with the session, right? So like basic things. For example, the state of the app. Is it minimized? Is it maximized? These are basic states of the app. These things are communicated through dbus with your stations dbus, like the session that you are currently having, via this dbus stations. Like this slot gives the snap access to use this dbus name org.gtk.example in the session bus to talk with the session bus as with the name org.gtk.example. You see, that's why this is a name, this is an ID. This just you can put anything here. The station dbus interface, you can put anything here. This is just for the sake of readability. So the interface that this is using, this is the interface that is defined in Snapd with AppArmor predefined set of rules. So we are using dbus. The name is org.gtk.example, which this app is using. Not in our hands. I think I can show you in the source code that how you can know the name that this one is using. Let me just see if it is inside. I can show you. So you see here in line 35, this app is registering itself with this name org.gtk.example. This is how you get to know which dbus ID the app is going to use to communicate with your station dbus, right? So so next up comes the main part. That is building your snap, building your app inside the container. This is the part where we get the source code, we build it with various ways. Like if we may use CMake, we may use Mason, we may use any kind of build system, we may use even shell scripts if we have. So we're saying source, we're saying plugin dump. The plugin can be anything. As I said before, the build systems are the plugins. CMake, Mason, anything you can think of, Python, anything you can think of. And then the source is dot. That is the current working directory. So that's being denoted here. And then we are overriding the build because we are not using any plugin. So we are not using any predefined template of build methods. We are overriding the build. So that's why this keyword denotes override build. And then this is a basic bash one, which says to show all the errors and all the executions. We are entering into the source directory that contains the files, and then we are running the same command that we ran previously in our bare metal. And then when the building is done, we are going out of that part, and then we are saying this craft control default. Why we are saying craft control default? What does this signify? So you see here, what plugin dump means, whatever is in that particular part, you end up like you just end it into the final snap. Like whatever file you have in this part, like whatever file you grab from a source, or however you can use even nano or cat to write things here. So you take the, like you use the plugin dump to actually end up having this files in the final snap file that you build, and then in the build packages. This comes up build packages. What it means is that the packages that are required, for example, package config, we are using package config. So this package config might not be in the extension that we have added. So we are pulling this out from the Ubuntu repo. This build package is actually coming from the Ubuntu repos. So as you might say, remember previously that we are using base 424. So this package is coming from the 424, the 24.04 repository. So this is the whole Snapcraft YAML, and now those who ran Snapcraft -v must have got a snap file, hello world gtk underscore 0.1 and then .snap as a file, right? So let's install the snap. So run like if you open the docs, you see you can get the command, or if you want I can also show you directly right now. So to install the snap, you run this command. Just a minute, please. You run this command, sudo snap install, then pointing the snap file, and then a flag named dangerous, because you are not installing this from the store. You are installing a local snap. So you've got it installed, right? Just give it a try, install it. What was the So anyone else here who have been able to successfully build this .snap file, those who have this .snap file, can they install it? Can you please install it using this command that you have shared? Is this visible? Is this screen visible? So can you see this command? Can you run this? Maybe you can just copy paste directly from the walkthrough documentation. Run the specific application or the specific executable. Like for example, for LibreOffice, you have multiple ones, right? So you want to run specifically LibreOffice or Start Center. So you can like the snap name, the unique identifier, and then then the app name that you had there. Here in the case, hello world GTK, because both of the snap name and app name here is the same, so we don't need to specifically mention it. So basically what I'm saying is, those who have been able to successfully build this app, they can run this command. This will also run the snap. They can also run this command to be exactly sure that they are running the snap. And if they want to be extra more specific, they can also run this command. This can be with both snap run and as a binary.
Yes, this form is especially important if you have more than one binary in one snap, yes, so that you can access them all. You specifically point that this is the app that you are trying to run.
Can you run this command as folder?
Yes, you can run this in any. Yes.
This is the snap with multiple parts, right?
Yes, a snap can have multiple parts. Yes, no, not multiple apps, not parts. Multiple apps.
In the Snapchat YAML.
Yes, multiple apps.
Oh, okay, multiple apps.
Yes, apps are the executables. So you, as you have been able to build it. Notation, for example, for a snap which has more than one binary inside. For example, the cup snap has all these command line utilities which one has, which
which cup says for listing the printers, for printing itself, and so on. And so there are many individual apps inside this snap.
Right. So the essential idea is that this you can obviously use both, but I don't think that will work. Like there's no app. Because that's how the thing is complete setup. So can you ask anything specific about it?
And you see also with this command here that when you have when you run an app of a snap, you can also supply command line options to it, and this makes it also possible to snap command line apps.
This type. This will only work when it's been fixed. If you not share it with the computer.
So why would you prefer like Snap or something like that?
Can you auto like can you create an app or a Debian like any package for let's say a very critical system with cups? Can you have a package for cups where you are reading one package one single time and it will run in any single distribution that has Snap that can have Snap.
Is that only specific Snap?
We're not